Hi everyone, welcome back to the channel. Today we are diving into one of Python's most memory efficient features, generators. If you have ever needed to work with large datasets or create sequences without loading everything into memory, generators are your go-to tool. In this tutorial, we will explore how they work and with some practical examples. Let's get started. Generators produce sequences one value at a time using the yield keyword. Brilliant way to produce sequences, enabling lazy evaluation that saves memory when working with large or infinite datasets. They enable memory efficient lazy evaluation for large or infinite datasets. Unlike lists that store all elements upfront, generators compute values only when needed, pausing and resuming execution to deliver a stream of data efficiently. For example, in a data analytics pipeline, you could use a generator to yield processed records from a massive log of user interactions like clicks on a website, allowing you to analyze millions of events without overwhelming your system's memory. They are used in data streaming loops and processing pipelines for scalable code, empowering you to write lean, high performance Python code. To understand generators, let's create a generator function that yields even numbers up to a given limit. This is a great way to see the yield keyword in action. Define even numbers. So this function is designed to yield an even number up to a limit. Current equals 0 while current less than max num yield current plus equals 2. Let's break this down. The even number function takes a maxNum parameter. Inside, it uses a loop to yield even numbers one at a time using the yield keyword, pausing after each yield until the next value is requested. When you iterate over the generator with a for loop, it produces things like 0, 2, 4, 6, and 8. So you get the parameter as the maxNum, you set current to 0 as long as it does not exceed the maximum limit, you yield the current value and add it to, so you go for the next even number. If you want to use this, you should do something like that. Say evens, use a variable first, even numbers, so let's say 10, and you should use next keyword here. Here you use yield. Now you should use next evens by using this variable. So it will print 0 in example. If you do that again and again, it will just print the next ones. Let's run it. As you can see, it shows 0, 2, 4, 6. Let's do once more. Now 8. Let's do once more again. It traces stop iteration. So it's a custom type of iterator, as you can see. It uses next keyword too, but as a difference, it uses yield in the function. Each next call resumes the function, yields the next even number, and pauses again. If you try to go beyond the limit, it raises stop iteration just like a regular iterator. This lazy approach is what makes generators so efficient. No need to store all values in memory at once. Besides generator functions, you can create generators using generator expressions, which are like list comprehensions but use parentheses instead of square brackets. They are even more concise and great for simple sequences. Let's try it. Let's say squares equals inside parentheses x raised to the power of 2 for x in range 5. Then we can use a for loop to print it. For square in squares, print square. can observe that it prints starting from 0 until 16, so from square of 0 to square of 4. Unlike a list comprehension, which builds the entire list in memory, this generator expression yields one square at a time only. For example, if you are generating a million squares, a list comprehension will store all million values, but a generator expression keeps memory usage low by producing values on demand. Generators are a game changer in real-world Python projects, especially for handling large datasets or streaming data. Imagine you are building a data pipeline to process user activity logs from a website, like clicks or views, stored in a massive database. Instead of loading all logs into memory, you can use a generator to yield each log entry one by one, keeping your application fast and lean. Let's define stream user events was for event in events. So what we are going to do is simulating a database query. So let's type a query if event type equals click yield event. So it's a generator, as you can see, and define a list of events here. So events equals user ID 1 type view item book, and let's populate the list. Just copy and paste, say click movie game. Again, click on book, and exit website. Now let's use our generator to filter out events. For event in stream user events print event. This generator yields only click events, processing one at a time. Let's run it. It only prints click events. So in a real app, you could connect this to a database query, streaming millions of events without loading them all into memory. Great for reading large files, generating infinite sequences like Fibonacci numbers, or streaming API responses in web apps, making them essential for data science, web development, and automation. Generators can only be iterated at once, so convert to a list if you need multiple passes. And if your generator uses resources like database connections, ensure they are closed properly. And that's it for our deep dive into Python generators. We have explored how they use yield for memory efficient sequence generation, built a generator function and expression, and seen their power in streaming data for real world apps. If you enjoyed this, give it a thumbs up, share it, and subscribe for more Python tutorials. See you next time, and happy coding!